Well, pre-calculus classes, good morning, good afternoon, or good evening. I know with the first part of 4.1 was a really long set of notes. This next set shouldn't be anywhere near as long, so that's probably some good news. But what we're going to do is certainly talk a little bit more about some things with angles and also radian measure. There will be probably some topics that kind of go back into what we did in the first part of the notes too, so certainly if you have those handy, that might be helpful. But first thing that we are going to talk about is arc length. And arc length is a part or fraction of a circle's circumference, which I know I'd mentioned in the last group of notes. Circumference is 2 pi r, and that's why, one revolution we treat as 2 pi, assuming that the circle just has a radius of 1. So there are technically two formulas for arc length. One is if you're using degrees, one also if you're using radians. The radians one will be the one you'll actually prefer to use, and you'll see the reason for that in a moment. So again, arc length is a part or a fraction of a circle. Well, so again, the angle that you're given, because we're not using the entire circle. So S is the letter we use for arc length. So you take whatever angle theta divided by 360, the entire circle, and then we multiply by circumference, which is 2 pi r. And so this can be simplified a little bit because 2 over 360 is 1 over 180. So that's kind of where that whole, basically it's r theta times pi over 180. You're using that conversion factor. And you'll even see the reason why I'm writing it this way here in a moment as well. Now, if you're working with radians, well, one full revolution or rotation, whatever term you want to use, is 2 pi. So again, you're using a portion of the circle, so theta over 2 pi times the circumference, 2 pi r. Well, you have 2 pi here and here, those cancel. So if you're working with radians, the arc length formula is just r theta. Again, that's the reason why I kind of wrote this in what maybe looked a little odd initially. Degrees r theta times the conversion to convert from degrees into radians. So there are the two formulas. All right, so let's say a circle has a radius of 4 inches. Find the length of the arc intercepted by a central angle of 210 degrees. Basically, when you are given a problem, like right here, central angle is 210 degrees, that means we're going to use this formula. So r is 4 inches, theta is 210 times pi over 180. Now, from here, what I am going to go ahead and do is now actually write that as a fraction and reduce it. So that's going to be 4 times, cross out the zeros, 21 over 18 is 7 pi over 6. And then from here, what we can do, that's 4 over 1, 28 pi over 6, or 14 pi over 3 inches. Again, arc length is what we are solving for, so we are going to go ahead and use a label there. You can certainly actually multiply out with the pi button if you want, but if I can leave it as an exact answer, I'm going to. So there is first example. Find the radian measure of a central angle of a circle with a radius 20 inches and arc length of 6 inches. So now they are asking us for the angle. Now again, keyword here, find the radian measure. So S equals r theta. And arc length is 6 inches, radius is 20 inches. And so this one's actually a lot easier than one we just did. 6 over 20, so theta is 3/10 radians. Here, because you don't have pi in your answer, we do need to go ahead and specify a label there. So there are a couple of fairly simple examples. One final example, a little bit more complex, and now is also where, some of the things we looked at in 4.1 day 1 are going to come back into play. So San Francisco has a latitude of 37 degrees, 46 minutes, 39 seconds. Seattle is directly north, has a latitude of 47 degrees, 36 minutes, 32 seconds. Given that the radius of Earth is approximately 4,000 miles, how far apart are the cities? Well, one of the things I always like to do with this example is just kind of real quickly sketch, we're going to say this is Earth. So, needless to say, I'm not a good artist, and I'll probably prove that for you guys throughout this chapter when we do some examples. But it says San Francisco is here at 37 degrees, and Seattle is due north. So basically what they're asking for is this little arc here. Tell us the radius of Earth is roughly 4,000 miles, and then our angle is there in between. So from here to find theta, we have to subtract. And before we do that, I'm going to go ahead and do the conversion. So 47 plus 36 over 60 plus 32 over 3,600, subtract 37 plus 46 over 60 plus 39 over 3,600. So theta is roughly 9.83 degrees, which I realize doesn't sound necessarily like a lot, but when you're talking about the surface of the Earth, 4,000 miles in radius, it's going to be a pretty good distance between those two cities. So from here, now, again, since we are using degrees there, r theta times pi over 180. So the arc length or distance between the cities, radius is roughly 4,000 times theta times pi over 180. Now, for this one, I'll be honest, we've already got a decimal that we've rounded off here. Also, when we're talking about how far apart two cities are, I'm going to go ahead and just multiply the entire decimal out. When we do this, I'll actually kind of talk about it as we go, but 4,000 times that answer, and then divided by 180. So you could obviously say, well, it's 218.48 pi miles. Well, think about if someone asked you how far away you live from school. You don't say, oh, I live about 3 pi miles away from school. You would say, I live 9 miles from school or whatever. So go ahead now, use the pi button, and it's around 686.36 miles. So that's that. I mean, certainly if you leave it as 218.5 pi miles, I'm good with that answer. But for this one, just go ahead and get that full decimal out. So again, as I mentioned, the second part of these notes, definitely quite a bit shorter than the first.